In the last lecture module, in talking about both the potential benefits of critical thinking and talking about the different topics that we'd be moving through as we progress through the term, I talked a lot about formal inference and decision-making systems. And one of the features of this class is that it will contrast our native inference and decision-making processes with formal systems, bug fixes, and workarounds that have been developed by incredibly intelligent people over the last few millennia of Western civilization. And so what we want to see is why it is that these two things are different and how they complement each other to give us a better set of tools for making inferences and solving problems. So remember, our native inference and decision-making capacities are highly contextualized. That is, they are driven primarily by information about the specific objects and properties, the things that you're solving the problem about in this particular case. And they're also driven very strongly by information about how the problem or the inference is being presented to you. So this information can drive a lot of good inference and decision-making processes. However, what these incredibly intelligent people across multiple millennia of Western civilization have come to realize was that lots of these problems, they have another element that you need to address oftentimes to make a good evaluation, to make a good inference or a good decision. And in the case of deductive logic, the first person to really understand that and to utilize that was the ancient Greek philosopher Aristotle. And what Aristotle discovered is, in his system of categorical logic, which we'll study a little bit later, there are two things that a good argument needs in order to work well. The first is content. It has to have good premises, good initial information. But the second thing is its logical form, that is, underlying structural relationships that need to work and be taken into account in making that argument or evaluating that argument. So any good argument has to have true premises, but it also has to have an underlying structure such that if the premises are true, the argument structure guarantees that the conclusion will also be true. So content and form, two elements. Now we're sensitive naturally and innately to features of content, but we're relatively insensitive to logical form. Underlying structural features of problems are relatively opaque to us most of the time. And to kind of illustrate that, let's just use a sort of visual metaphor here. So here's a picture of somebody's tattoo. And we look at the tattoo in normal light. It's like solving a problem or making an inference, making a decision using our native inference and decision-making capacities. So we see certain features about the tattoo here in normal light, just as we see certain features about the problem when we're using our native inference and decision-making capacities. However, those aren't all the features. And so we can imagine that a formal system is like turning on a black light. And what happens when we use a formal system is we rewrite the argument to make that underlying structural stuff explicit so that we can take advantage of it. In the same way that flipping on that black light suddenly makes all these things that we didn't see fluoresce and become obvious to us. So a formal system will take features that are there, that are important, but that aren't obvious or that we're particularly sensitive to using our native inference and decision-making capacities, and it will make them explicit so that we can utilize them to make arguments and to evaluate arguments. Now, to give a concrete example of that, let's consider a couple of different arguments here. Here's argument number one. If dogs are cats, then Wallace is a genius. Dogs are cats, therefore Wallace is a genius. Now, if you looked at this argument, you'd say, well, this is a terrible argument. All right? And it is bad, but it's only bad in terms of its content. It's not bad in terms of its logical form. So consider this argument. If this liquid is water, then it consists primarily of H2O. This liquid is water. Conclusion, this liquid consists primarily of H2O. Now, this argument should seem like a very good argument to you. The amazing thing about these two arguments is they have the same underlying logical form. They relate their content elements in exactly the same way. And in fact, they relate them in such a way that these are both good, valid deductive arguments. And we can see what that shared underlying structure is if we take out the content and just look at the relationships. So both of these arguments have an underlying structural relationship. They say, if this first thing is true, then the second thing also has to be true. So they have a conditional statement that relates the truth of one thing to the truth of another thing as their first premise. Then they have an assertion that that first thing is in fact true. And then a conclusion that the second thing must also be true. Now, this is such a common and widely recognized inferential principle that its name is actually a Latin name. It's called modus tollens, and it's a conditional inference. I have a conditional, I have the antecedent for the conditional, I'm entitled to make an inference to its consequence. But these arguments, they share good logical form. They still differ, however, in terms of their content. So that first argument has false statements that arguably all the statements are false. So maybe the first one, since it's meaningless, wouldn't be. So if dogs are cats, then Wallace is a genius. I don't know if that's true or false. It's hard to even imagine what would make it true or false. Dogs are cats. Well, that's just clearly false. Unless you are a fan of the cartoon of the 90s, Dog Cat, then dogs just aren't cats. And finally, our conclusion, also relatively implausible. Our second argument has a true premise and then a second true premise. It has a true conditional statement, it has a true antecedent, and so we're allowed to make an inference to that true conclusion. Now, we could make that same transition from premises to conclusion if that first argument, in fact, did have two premises. If it really were the case, whatever that means, that if dogs are cats, then Wallace is a genius, and it really were the case that dogs are cats, then Wallace really would be a genius. So there is this underlying structural relationship shared by these two arguments that is a good structural relationship. It guarantees that if the premises, if the initial information is true, the structure of the argument will also guarantee the conclusion is true. Now, they differ in content, and for that reason, the first argument is awful and the second argument is great. But they still are arguments that have a similar structure to them that we're not particularly sensitive to when we make conditional inferences. And so by looking at formal systems, what we do in formal systems is we pull out, we make explicit those underlying structural features, and then we use a method to process them. And so we can evaluate arguments when the content and the context aren't as important as the underlying structural features. And this allows us an alternative way of looking at arguments that allows us to catch bad arguments that content might not help us catch. So we'll finish the second lecture here with one final module to talk about one final point.